Hello friends, today we are going to discuss a physics question from NEET 2016. So the question states that what is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop. So what is given is that there is a vertical loop and we have been asked uh, the minimum velocity with which a body of mass m should enter the loop. So I request you all to please pause the video and attempt it in your capacity, and then we will discuss its detailed solution. So I hope that all of you would have attempted this question, and as I always suggest that before starting attempting question, please make a rough sketch of the question. It will help you in analyzing the question and formulating what strategy, what formula which you are going to use. So I have drawn a very simple diagram here, and it is given that the loop is vertical, and we have to find the minimum velocity with which a block can enter so as to make a complete revolution. So first we will decide that where should the body enter so that it takes minimum velocity to complete the loop. For it, we will use the energy conservation equation, and as I have written, I have assumed the velocity at lowest point as u and velocity at highest point as v. So I have used this energy conservation. At the lowest point, I have assumed that potential energy is zero, so only left is kinetic energy. The total energy at the lowest point is half mu square, which has been written on the left side, and on the top side, I have assumed the velocity v, and here the total energy will be 2 mgr plus half mv square. That is, potential energy is 2 mgr and kinetic energy is half mv square. So, uh, where do you think that the minimum velocity uh, will occur? The minimum velocity will occur at the topmost point, because here if we will solve, we will get v square is equal to u square minus 4gr. So here will be the minimum velocity. So we will have to find v. Now in order to find v, we will draw the free body diagram of that body at the topmost position of the loop. So as I have drawn it, the normal is acting downward, gravity is acting downward, and the what you call as centripetal force is acting in upward direction. So I have just equated the force on both sides. It comes out to be n plus mg equal to mv square upon r. So in limiting case, normal reaction will be zero. What is meant by limiting case? Limiting case means that situation where the block tends to fall, and when the block will tends to fall, it will when the normal reaction between the loop and the body is zero. So that is why I am making n equal to 0. Now calculating, we will get v equal to under root gr, and this will be our required answer. So our answer will be option number 4, under root gr. Now many students were confused by the option number 3, under root of 5 gr, and in most of the coaching classes, in even in schools, it is taught that under root 5 gr is the minimum velocity at the lowest point so that the body can complete the loop. But here the question is different. The question is asking what is the minimum velocity with which the body enters the loop. Now the body can enter the loop either at topmost point or at bottommost point or at anywhere in the loop. So we have to calculate that velocity. If it is entering at the topmost point with velocity under root gr, then it will complete the loop. However, if it is given that what will be the minimum velocity so that uh, the body will complete the loop upon entering the lowest point. In that case, the question is asking to find the value of u, and that is under root of 5 gr. So uh, be conscious when you are dealing with such tricky question, and I hope that all of you would have understood the question which has been discussed. So please like and subscribe our channel, and if you have any query, please feel free to mail us at questionclasses@gmail.com. Thanks for watching.